Oh, now you said hello. This is rolling. We can start. Okay, I'm just avoiding awkward poses in the beginning of the YouTube video. That's why.
My job here is done.
Huh?
My job is done.
Oh no! You won't be off the hook so easily. Okay, hello and welcome, and thank you all for coming. Great venue. I love the the ambience. Feel free to eat and drink. It will make us actually feel better. We know that your time won't be wasted, even if you didn't like the talk, but you will. Okay, so we're going to talk about developer productivity. It has like a strange name, obviously suggested by ChatGPT. It's not that we write our own abstracts anymore. And it is like a dual perspective on best practices and testing. And then you go like, what the fuck, dual perspective of developer productivity? Maybe it's coffee machine and noise cancelling headphones. Which kind of, dual perspective on developer productivity. Both of them are important, but today we're going to talk about the engineering aspect of developer productivity. My name is Baruch Sadogursky. I'm at Baruch on whatever social media is trending or called this week. Developer productivity advocate, that's what I do for Gradle. Who knows the build tool? Everybody knows the build tool. Who knows that it's not only the build tool? Okay, yeah, we'll talk about that a little bit today. And this is why they pay me the big bucks and for being here, but I will do my best to restrain myself from doing a very blunt product pitch. It will be a mild product pitch. Anyway, Java developer back in when Java 8 wasn't even a thing, when Java 1.4 was a thing. And then I worked with JFrog for 11 years. And we pivoted with JFrog and with Artifactory from development to DevOps. Now I'm back kind of working with developers, talking about developer productivity engineering, hashtag DPE. We're going to hijack this hashtag. It now belongs to some weird, any French-speaking people here? Yeah, so you will know what I'm talking about. I think it has something to do with construction codes. It's like 3 words in French that I try to memorize, but I don't remember. Never mind. But forget about it. Developer productivity engineering starting today. Couple of books that I co-authored, DevOps tools for Java developers, which kind of brings both my Java and DevOps background, and the Liquid software, best practices on how to release software in our Liquid day and age. My partner in crime today, Aleyner, and he's a co-founder at Atomic Jar. Who knows test containers? Same people who know Gradle. Same deal. We will talk about test containers a little bit and stuff which is not only test containers. Very impressive resume. Founding team at AWS. Anyone heard about S3 maybe? It's this guy. It's this guy. How about Bing, the search engine? Maybe this guy. And how about Pivotal, Cloud Foundry? Also this guy. Very, very impressive, right? I'm really honored. Okay, the most important slide of this talk is this. If you go to speaking.jbaruch and note how I hijacked Switzerland top-level domain for the purpose of this URL. Thank you, Switzerland. Yeah, if you go there, there is a page there dedicated for this talk tonight. It already has the slides. It will have the video if I tapped all the buttons correctly on my phone. And it has all the links. Everything that we're going to talk about and already mentioned, like the books, but also everything else is there. So in case this URL is hard to remember, I make it easy on you. It's in the bottom of each and every slide. Together with our Twitter handles, the Twitter handle for JUG, and the hashtag that we are actively trying to hijack, the DPE hashtag. I'm working on it, you see. Okay, let's talk about productivity. And conversation about productivity, I want to start with conversation about motivation. They are very closely related concepts because in the end of the day, they are related through very important things to us as developers. Daniel Pink, an amazing author, one of my favorites, wrote a lot of great books. One of his best is Drive. Drive is the book about the surprising truth about what motivates us. Basically about motivation. I don't know about you, I was walking around sure that the motivation of humans is pretty basic thing. It works with carrots and sticks. You pay them enough money and they're motivated. You take enough money out of them and inflict physical pain, and they are less motivated or motivated not to do that, whatever they just did anymore. It turns out that while it is true, it's also not true, especially for intellectual workers, which apparently some people consider developers. It's a debate, I know. But let's assume for a second that it is. And then it turns out that when we kind of take money off the table, we have enough money for our lives, actually other things can kick in. And the three things that kick in are autonomy, mastery, purpose. Now, I want each and every one of you to think for a second how those three things, autonomy, I can work by myself, I'm not micromanaged. Anyone enjoys micromanagement? Well, Eli, you enjoy micromanagement because you inflict it. Anyone enjoy micromanagement from being like managed? Not really. So yeah, autonomy, you can do your own thing, you are not micromanaged. Mastery, you're good in what you are doing and you are getting better. And purpose, what you do actually matters, right? So mastery, you use the best tools, you kind of enjoy how awesome you became lately with those new shortcuts in IntelliJ, right? And then purpose, you actually see your code running in production somewhere and someone actually uses it, and that's pretty awesome. That motivates us. So there is a lot of truth about that. And the question is, okay, thinking about it, yes, that makes sense. What it has to do with productivity. I will give you a couple of examples that kind of ruin our productivity, and you will see how they correlate to those motivational things. For example, the flow. Where we are in the flow, we are all very, very productive. When we're kicked out of the flow, for example, our build, our build takes forever, and we are distracted to do other things. We have this context switch, we go to read emails, we do other stuff, and then context switch is really terrible. Because coming back is very, very hurtful. And I won't even ask you to vote. I know for sure that each and every one of you experienced that. Right? What does it do to your motivation? What does it do to your feel of autonomy and mastery in this example particularly? And you know what? Only 84%, I don't know what's going on with the other people, how other 16% feel, but 84% feel that it's a real pain. Too much time spent waiting on build and test feedback, either locally or during CI, from people who we asked, 84% agree. And then another source of frustration, stuff like flaky tests. I have a flaky test in my test suite. It runs last, sometimes it passes, sometimes it fails. And this is extremely annoying, especially when this test has nothing to do with my code. And you know what? Maybe the flakiness, it's not even comes from validation logic, but it's an environment which is unstable. Isn't it annoying? Of course it is. And what do we do when it happens? Just run it again and hope that it will pass. Sometimes it does, but you know, yep. 65% agree that inability to easily troubleshoot and determine the root cause of tests, including flaky tests. I guess the other 35% don't write tests, so they don't have this problem. But yeah, another example, boiling the frog. I have a feeling that everything is slower somehow. Well, we feel that with our laptops and with our phones, right? After a year or two, it's like, well, how it is so slow? But we know what to do, we just upgrade. What about our build? We feel that it slows down. We are not sure why, and it's maddening as well. It hits us into autonomy. We need to ask other people for help to see what's going on. It hits us obviously in mastery because we're not productive as we want to be. And more than 50%, almost 60% agree that this is a problem as well. So basically, developer productivity is very tightly related to autonomy, mastery, and purpose. When we are productive, it especially helps our mastery, and it also helps our autonomy. And also we're productive working on stuff that matters, so it helps us purpose as well. And it highly obviously related to motivation. Autonomy, tools and people aren't in our way. Mastery, tools and processes help us to excel and not in our way. And purpose, the productive, the whole product in what? I should make a joke. You cannot take product out of productive. And product, this is our purpose, right? This is all of us work to actually do something. So obviously they are all very, very closely related. And here is an idea. Developer productivity engineering is something that we all can do in order to make us all more productive. Now, why I'm stating that all of us can do it? Because of the engineering part. All of us are software engineers. We know how to engineer stuff. So let's engineer developer productivity. How do we do that? Here are some ideas. Foster faster feedback. One day I will be able to say it from first try. Foster faster feedback. What does it mean? You have some ideas. Well, I want my build to be faster. I want my tests to be faster. I want to know more about how what I'm doing, is it good? Did it break something? Faster. Eliminate toil for developers. This toil of, hey, I need to rerun the tests now because there is a flaky test. Or toil of, I completed some task, I pushed my code, I created a pull request, but now I also need to log into another system in order to move the ticket from one column to another. This is toil. Do we know how to eliminate it? Hell yes. Let's do it. Collaborate through effective tooling. Again, a very engineering challenge. How do we explain someone else that things went wrong on my build? Or that something is not as performant as it used to be? Well, I feel that my build is slow somehow. You know what? Just go away. I have no way to help you when you describe it this way. Show me a trend with numbers that I can dig from this trend deeper and compare what actually changed. I can help you. Collaborating through engineering tooling is collaborating through effective tooling. Prioritize automation and eliminate bottlenecks. Again, engineers. Who read the Phoenix Project? Not enough of you. You all should. It's a book about DevOps, which all of us should know something about anyway. But it actually talks about a previous concept that DevOps kind of born out of. It's called the theory of constraints. Anyone heard about theory of constraints? Again, not enough. There is another book called The Goal, that the Phoenix Project is kind of just a rewrite of The Goal, that talks about theory of constraints as a novel. Very nice. And the main idea is that the only thing worth improving is the bottleneck. Because if you optimize not in the bottleneck and the bottleneck remained, you didn't do anything. This is true for our working process as well. We need to find the bottlenecks, we need to improve them, and then move forward. Embrace rigorous observability for proactive improvement. This is something that I already mentioned when I spoke about the performance slides. If we didn't observe it, we have some vague idea that everything is slower. We need to actually observe what is going on. Now, observability being the hottest thing in the industry for the last years, but for production environments. Obviously, it's been there because it's super important, and this is where it kind of came to be, and now it's thriving. There is like every second company is observability, the other one is security, and that covers the entire new landscape. But what about the observability of our work? Do we know what's going on in our working process? We should. Outcomes over output. Obviously, the more tools we use, the more complicated our setups are. There are here and here. Yeah, come in. There is space. There is space. Also over there, if you want. So yeah, the more complex our ecosystem is, the more noise it generates. and it does. How do we actually take what matters, outcomes? You can watch this screen, I guess, right? Is it too small? Or really, there are seats here that will work better for you. Yep, here you go. No, here is great. I'll try to speed less. No promises though. Oh, you're in the right t-shirt, you're good. Okay, right, so we will try to take like the outcomes out of it. And something that is very critical. Now, a lot of those are done for production environments, right? I mentioned observability, hell yes. Eliminate toil, done for production environments and for your CI/CD processes. Automation and bottlenecks, this is what DevOps is about, right? But it's all about the product. None of it's about our productivity. Why? Because of the mindset. Everybody are obsessed about the product. How fast we release it, how smooth we release it, how good is the quality. No one thinks about the productivity of engineers. We have to change it. We have to make sure that our productivity is on top of organizational mind, and it actually requires dedicated effort. And the best companies out there, your Snowflakes, your Spotifys, your Netflixes, the Ubers, Lyfts, they have dedicated teams that work, all they do is work on developer productivity engineering. And this is how it should be. And we're all here hearing about DPE to then come back to our companies and make sure our companies have the dedicated organizational mindset. Okay, let's see what we can do tomorrow. Tomorrow is, Friday. Tomorrow we're working. So what we can do tomorrow in order to make it happen. There are small improvements that can make a huge difference. For example, use better IDE. How many of you write code in Notepad? No one, thank you. How many of you use IntelliJ? Almost all of you. The rest use VS Code? Eclipse? Okay, well, it's all downhill from there. Use better IDE. It's the single most effective thing to make your writing code process more effective, right? And it's easy. There are free solutions. VS Code is free. Community edition of JetBrains is free. JetBrains gives away every month 2 licenses for every JUG to raffle away. If you come to this JUG enough times, there is 100% possibility you will end up with IntelliJ license. It's easy as that. Test better. Test containers. Ellie will tell us all about it in a second. But yes, your tests, if they don't suck, they at least can be better. How they can be better? By finding the sweet combo of being production-like and blazing fast. Are you intrigued? You should be. Ellie is next. Enforce better code. Sonar Cube, Sonar, whatever the other product is, the linting, Sonar Lint, whatever the other product of Sonar is. They are great tools to make your code better. This is yet another quality gate that you can bring to your process to make sure that you're working more efficiently. Test more reliably. Flaky test detection. How do you detect flaky tests? Well, if you have a test that fails sometimes and passes sometimes, this is a flaky test. How do you know that it does that? You run it multiple times. You observe. What do you do with that? You actually do something about it. It's not something, it's sometimes not your responsibility, and sometimes you have other things in mind, and sometimes it's harder it's easier to run it 3 times, see it pass and forget. But getting back to the organizational mindset, we need to do something better with it. And there are tools like a tool from Gradle that it's called the Velocity that actually takes care of that for you. But you know what? You're all engineers. You have already in mind how to do that. How you can automatically find it, how you can automatically tag it, and how you can generate a report of flaky tests and send it to the right people who can use it. Am I right? Everybody know what to do? We're going to do job interviews. This will be your what you need to lay out the architecture of the thing. No, seriously, you know how to do it. And foster faster feedback. Now, foster faster feedback, I started with it in a previous slide as one of the most important things. And I will repeat how important it is and what can you do in order to make it happen. So let's talk about feedback efficiency. Feedback efficiency, it's something that you experience every day. When you type your code in the IDE and it highlights it red, this is your feedback. You know that you missed a character, you forgot a semicolon, or did something else. This is a sub-second feedback efficiency. Build. You want it to be very close to that, right? But we want it to be seconds. But realistically, who has build that takes seconds? Like, not hundreds of seconds. Okay, fine. But actually, I guess most of us under 10 minutes, around 10 minutes, something like that. More than 10 minutes. We need to work on that. Yeah, okay. And then again, we won't get into horror. So it's Halloween, maybe we should. CI, minutes, you know what? Hours, you know what? Who cares? And then production, hours, days, month. I won't say who cares because we should care, but I would say it's not critical how long this feedback is because we don't really wait for it. Well, I hope we don't. Okay, I made a pull request. Next time I work is after I see this one in production and check that it works. That's not really how we do things, right? So the lower we go, the more farther away it is from developer, the less we wait for feedback. So it's reverse dependency on distance from developers, IDE, build, and then CI and production, right? Now, build is an anomaly here because it's very close to developers. We run it all the time when we write code. After each couple of statements that we wrote, we want to check that, that it's okay. But it's not seconds. It's actually minutes, tens of minutes, dozens of minutes. So the build is outlier here, and we all know that it's acknowledged in classics when XDHK have a comic about it. Now, how do you feel about it? You maybe giggle for the first time, but this is actually, excuse me, bullshit. I don't buy it. No one is happy that their build is slow. No. Maybe for the first time we have time to do that. After 20 times that we run our build every day and it's still slow, we won't enjoy it anymore. So, not really. It is slow and it is maddening. It's not fun. Now, there is one more problem. Build is a complicated domain by nature. We can kind of hide the complexity and then reduce with that the usefulness or the versatility or the flexibility of the build tool, and then look at you, Maven. Or we can go the other way around and we can expose the entire sheer power of a build domain on non-suspecting developer and then just bury them under the complexity of the thing, and then look at you, Gradle. Right? So here, Bruce Eckel, the author of Thinking in Java, that a lot of people, I think among us, also learned Java by his books. One of the smartest people in the industry, for sure. And he's like, you know what, fuck it. Gradle is too complicated for me. I need to know everything about build in order to do something, and that's not my job. I don't want to learn everything about build. So this is a real problem. It's slow and the developers have no idea why. And this is even more maddening. Now, what do we do with that? What is build in layman terms? Well, project setup, we're downloading the internet, and then we generate artifacts by compiling, packaging, whatever. And then we test whatever we test, and then we deploy the artifacts locally, remotely, whatever, or just delete them, which is also fine if it's a local build. Now, what can go wrong? Project setup, downloading the internet, artifact generation, tests, and artifact deployment. Obviously. And when can it go wrong? At any time, basically. So in order to debug the build, we really need to understand all of it, which is very hard to do without the right tools that can help us. And this goes into the category of outcome over output, right? Build throws on us output. And I'm not only talking about the logs, I'm talking about the entire concept. It's output that we need to deal. Instead, if we can get only the outcome, only what's important, for example, when the build fails or when it's slow, what went wrong in the way that we understand, then we can do something about it. So the build frustrates the developers, and here's the idea of ChatGPT of how to speed up a Maven build. First item, skip tests. And I'm going like, what the actual fuck? The whole idea of the build is to get feedback. If I skip the test, I defeat the entire purpose. Maybe I should skip compilation as well? I mean, what can possibly go wrong? Tests and compilation are exactly the same thing. We wrote something and we want to check that it's correct. Syntaxically correct in terms of compilation, and semantically correct or functionally correct in terms of tests. They're exactly the same thing. We cannot skip tests. We want faster feedback, not less feedback. So what feedback do we want? Now when ChatGPT kind of argues with that we don't need tests, let's talk about what we do want. An example of, or not an example, a complete list of the feedback that we want can be found in our CI/CD pipeline, because CI/CD pipeline checks all of it. It checks compilation, it checks unit tests, it checks integration tests, it checks code coverage, it checks linting, static code analysis, dependency scanning, secret scanning, security static code analysis, load testing for non-functional requirements, resource utilization, and compliance. A proper CI/CD pipeline have them all. Now, how about that as a feedback? Well, not great, not terrible. Obviously, it's not terrible because we check all those things before our code gets to production, which is good. This is what we want. Why it is not great? It is not great because we are not waiting for the feedback before we're doing something else. There are two types of feedback, asynchronous and synchronous. Asynchronous feedback is the CI/CD. We never wait for it. It just runs whenever it runs. But if something is wrong and we need to get back and fix it, the results are very distracting. We need to drop what we're doing and go fix the build because the bunny is depressed. Eli, you'll tell them everything about the depressed bunny. Synchronous. Synchronous feedback is our build. We wait for it in the flow. But if we are going to pile all the quality checks into our build, it will be so slow that it will piss us off, right? So now, what can we do? Yeah, so the difference between the line between synchronous and asynchronous is obviously commit time. This is what we wait for. This is what we don't wait for. Now, what it will be lovely if we get all this feedback in our build. It would be great for how confident we are in the code that we produce, but the first thing you think is like, okay, my CI takes an hour, now my build will take an hour, I will go and shoot myself right now. You're Canada, you have nothing to shoot yourself with, but you got the idea. No, not a good joke? Sorry. I tried. Okay, this is what we want. We want maximum feedback, and we want it super fast. This is what we really want. There are two general principles in doing that. The first is skipping what can be skipped. And again, your engineers start thinking about how you can skip stuff inside your build. I will give you a couple of ideas. You can think of more, obviously. Incremental build works out of the box in any modern build tool. Better in some, less successful in others, but exists everywhere. How does it work? It doesn't build what haven't been changed. If you run your build, Maven, Gradle, Bazel, whatever, twice in a row, the first one will take whatever it will take, the second will be blazing fast. It skipped everything because the inputs are there, what your source files, and the outputs, your whatever jar file that you produced is there. So there is nothing to do. Don't build what isn't affected. When you have a multi-module build, microservices or what's not, the incremental build will understand which modules depend on which ones, and it won't run the tests and it won't build the modules that are not affected. Which is nice. It works out of the box, there is nothing to do with it, but it's not perfect. It's not perfect for two reasons. The first is it relies on produced artifacts to do the avoidance. For example, if you run clean build, it will build everything anew again because you deleted the jar files, so it goes like, well, we don't know what to compare to, we need to build everything anew. It also requires physical artifacts to do the comparison. You cannot say that my inputs are environment variables and my outputs are some variables in the code or in the build. It cannot do that. So it requires physical artifacts. The other shortcoming is that it relies on architectural decisions. When it decides what tests to run, it will look at your declared modules and how they depend on each other to decide what should we test and what's not. There are two problems with that. Sometimes we have a monolith, we don't have modules, so it will run everything all the time, or we just didn't break it well enough. The other is, well, in the ideal world, the API will never depend on the implementation. We don't live in an ideal world, and sometimes stuff breaks in unexpected places. Your incremental build won't know how to change it. This is one of the reasons why we keep running clean build, because we don't trust the incremental build. This is why we run clean builds all the time and make Andres angry, if you know what I mean. If you don't, never mind. There is a friend of ours is on a holy crusade of not running clean builds. Doesn't work for him very well. He's not sure why. I know why. Because we don't trust incremental builds. Maven has incremental build. We trust it even less. That's true. Okay, caching. Caching is the solution because caching don't have those two shortcomings. It makes the build faster because it actually calculates the checksums of the incomes, which can be anything, doesn't have to be physical artifacts. And then it archives the outputs and correlates it with those caches. And again, the outputs can be anything. It can be whatever virtual concept that you invent. So it does what incremental build does, but when you run clean build, it will still work. And it makes build faster for everybody. And what it means is that we can share those caches. If we have exactly the same project, and I just give you my caches, your build will be blazing fast because we have the same incomes that didn't change, and I just provided you with the outcomes. So it will actually work. Remote cache is an extremely powerful way to make the build faster for everybody, and it works just great. And it makes the build faster always, because remote caches are up to date somewhere. For example, on your CI server. Your CI server constantly builds. Even if you didn't build today, even if it's morning for you and it's afternoon for your colleague in Europe, their caches will help you to skip this first morning long build. Yeah, you might want coffee, so you will go there anyway, but if you don't want coffee and you want to start working, it will speed it up for you, even if you didn't build anything for a while. And it makes all the parts of the build faster because it doesn't rely on known in advance physical artifacts. Incremental build works for a very small set of defined plugins or tasks or goals, because someone thought about, okay, how do we correlate that in advance? Caching works for every task, every plugin, every goal in Maven or Gradle that you bothered to declare inputs and outputs. That's the only thing you know. That's the only thing you need. You throw a couple of annotations or a couple of code or XML in your build declaration. Those are the inputs of this task. Those are the outputs of this task. Boom, next thing you know, it is cached. It is very, very easy to do, and it will work for everything. So here's an example. As I mentioned, you already know how to cache stuff. I just gave you the algorithm, right? So you don't need any tool to do that. It also comes free out for Gradle, and Maven 4 has experimental support for caching as well. So you don't need to pay anything to actually make your builds much faster and you more productive. Now, this is a screenshot from Gradle Velocity, the product formerly known as Gradle Enterprise, that actually just visualize the savings. So this is what's here. You can see the avoiding. This is an Apache project called BIM. Gradle provides a free Velocity instance for the entire Apache Foundation, and we are lucky to pick on what they are doing. So this is BIM. Build time, 17 minutes. Avoidance savings, 47%. There is some gains by up to date. This is your incremental build. Almost 2 minutes. Well, not great. Local build cache, 9 minutes. Remote build cache, 3 minutes. This is where the real savings are. Caching. Again, out of the box, free, local. Remote also free. You need to set up your own instance for the remote node itself, but other than that, it's also free. Another way to avoid unnecessary work is only run tests that needs to be run. Obvious? Of course. $1,000,000 questions. How do I know which test to run? We don't. How about we throw machine learning on it? How about we teach the machine what code do we change and how tests behave, and then it will tell us what changes require which tests to run. Learns code changes effect de facto, skips test with high degree of confidence. The way it works, code changes and test results are thrown into the learning model, and then after a while the model predicts which changes fail which tests. It's a very successful paper that came out of then it was called Facebook research, now it's, I guess, Meta research. A lot of companies actually use this paper to implement predictive text selection. And it works incredibly. And the most incredible thing about it is how we can see the smartness of its learning and understand that it doesn't actually know why when it comes to those awesome conclusions. I will give you 2 examples. First of all, so what changed and where it changed, that's kind of the model. Correlate with observed test failures. Next thing we know, predicts which changes will fail which test. That's the idea. Couple of examples of how the machine predicts the results without understanding why. The more tests a project has, the less they break. For all of us, this is obvious. But it's actually proven by the clueless machine that actually just ran the observations and came to this conclusion. How about that? And the second, even funnier. Refactoring in Java break tests less than in JavaScript. And you go, duh, obviously. This one is strongly typed language. This one is loosely typed language. Obviously, the refactoring will work better. But the machine has no idea what we just said. All it knows that from this project, it breaks more. From this project, it breaks less. And boom, it actually makes sense. This is very cool. So if you go to speaking.jbaruch, you obviously have a link there for the research. It actually surprisingly digestible for being like a research paper. And it's not very long, and it's a great reading. I truly recommend, no sarcasm here. This is another example, another project that enjoy the velocity and we enjoy to see what they are doing is the Spring Framework. This is them. So they run simulations to teach the machine, and we can just observe how well the simulation predict the results. So 99.4% accuracy of total end goals failures predicted correctly. 99.4%. It actually missed 2 tests out of more than 24,000. How long it saves? This is a week view, 6 days. A week, like an entire developer on a Spring Boot team time. This is amazing savings. Almost 40% of avoidable tests. This is really cool stuff. Well, you might be worried about those 2, and you should be, because maybe they are very important and we just missed them. But remember, we are talking about local builds. We do all this thing for one purpose only. We want faster feedback on our local builds. What we don't care about? Async feedback. So what we're going to do in CI/CD, we're going to run all of them. Because we don't care about how long it takes. And then we will catch those 2. Yes, twice out of 400 times we will be very pissed off. It passed on our machine and it failed on CD. But you know what? We saved so much time that it's definitely worth it. Right? So this is predictive test selection. Again, something to think about and implement. Now, the other way of speeding up things. So we avoided everything we could. We cached everything we could. We test only what should break. But what about what can be cached or avoided? We need to speed stuff up. There are a couple, again, of trivial ideas to implement today. For example, test parallelization. Use max power of your local machine, and this is why your boss should buy you the bleeding edge. Now, I don't know if you know, there is an Apple event with the new MacBook Pros in, next week? October 30, right? Now, be ready, because next slide, I will give you one slide that will convince your boss to buy you the M3. Ready for it? Here we go. I have a project on my machine that runs for 2 minutes. The build. Most of it is test, like almost all of it is test, 159. I change one line of code, and it goes to 10 seconds. From 2 minutes to 10 seconds. 12 times difference. You know what I do? Use all the available processors for testing. Now, you go to speaking.jbaruch, you download the slides, you take this slide, you take it to your boss the week after next. Hey boss, did you hear about the new M3s? This is why you need to buy it. And they will. Because this is really convincing. You cannot argue with numbers. Okay, now you all have your new laptops, or maybe you don't. How about we utilize even more processors? You know who has more processors? The cloud. The cloud has all the processors. So we can, right? So we can run our tests, local tests, not CI, in the cloud. CI does it forever. It calls the fan out, it spins agents, it runs the test, great. But you should enjoy it for local tests. Your local build should be able to throw the tests out for the cloud and then just to collect results. You should use the cloud for distributing test load. And then you can run all the tests that needs to be run. No more, but definitely not less. Why not just use the CI infrastructure for it? You already have it set up. Because no one cares about how long the CI runs. So the CI infrastructure is usually not optimized for real-time feedback, and the agents are not as fast as they can be, because really, who cares? If it's synchronous feedback, you care about time, don't use CI agents. Instead, use something like test distribution feature to run this in the cloud. And the last part that I mentioned about everything is slow. Don't let it slide. Observe and improve. Measure local build times. The simplest thing. You just look how long your build takes and you take notice. You want to put it in Google spreadsheets? Fine. You want to reduce toil and automate everything and throw a small, what it's called Prometheus agent into it and record it and then show you a nice graph in Grafana? This is very geeky. Do that. But observe and watch. Detect downward trends and then find root causes and improve it. Again, if you have something like the velocity, it's there out of the box. If you don't, I already told you how to do it for free. Don't pay for this shit to Gradle. We will be fine. Do it yourself. Shit is recorded. Okay. I'll beep it out. So yeah, this is a trend that this is boiling the frog. You see how it climbs and then it's significantly slower. Did anyone notice? Not really if you didn't pay attention. So do pay attention. With that, let's talk more about tests. Eli.
All right.
Not yet. We're not done. I'm coming back.
All right, cool. Baruch told us a lot about build. He's also a very hard act to follow. I'm going to try it in any case.
You're fine.
All right. I wear the t-shirt. I'm wearing the DP t-shirt and his regard over here. Next talks you do in test containers t-shirts.
Just give me one.
Oh, okay. Cool, awesome. So we talked a lot about build. We talked a lot about test distribution. We talked about lots of things. Let's talk about tests. Anyone here excited about tests? One? No? Whoa, there we go. Whoa, yeah, don't be shy.
The idea is you all should say no, and then after Eli, he asks it again, and you're like, ooh.
Okay,
Come on, people.
I'm going to try it. All right, cool. Tests as we know them today, right? Trade-off. They're either expensive, slow, and production-like. Baruch talked a lot about CI testing. Or naive, useless, but fast, right? Mocks. All of us do mocks, right? They're fast. They give you fast feedback, except they're completely wrong, right? The choices we have are wrong tests, or we do staging environments, or we do CIs, or we do and wait and get asynchronous feedback that Baruch has told us about. Is there another way, right? I'm going to tell you a story. Baruch told you about my resume. I'm going to use some of it. So I used to be on the S3 team over at AWS. And at the time, the S3 team was fairly small, right? And we ship S3. You know, we need to be able to know that the quality of what we're shipping is fairly high, right? Because something might happen and we might need release. And we had staging environment where we would deploy all of our integration tests. And we're like, okay, no one pays attention. What are we going to do? Like, okay, we used to sit in a room like this, similar to this, similar size. And our managers are like, yeah, you know what? Let's put monitors all over the room with the status of our integration tests, right? Good idea? Okay. All right, so they put the monitors. No one pays attention. Why? Because it's there. How do they make us pay attention? Like, okay, great. Integration test was the main quality gate. They said, we're going to put a picture of a bunny, right? The picture of a bunny on those monitors in addition to the status of our tests. And the bunny would be happy-go-lucky, excited. 80% of the tests are passing. Bunny is happy. Carry on, do your thing, right? There we go. But, the bunny would be a little upset. And this was earlier times, a little bit less politically correct than today. The bunny would be bloody and massacred on the screen. And the idea was, hey, if less than 80% of our tests are passing, everyone has to rush and save the bunny, right? We have to go and save the bunny because the bunny is not feeling very well. And one of the things that I realized as I stayed on the team for a little bit longer than the average stay at Amazon, which was 8 months at a time, is that the bunny becomes much more depressed. It actually became clinically depressed over time, right? Because as the project matured, as we had more tests, as we had more things out there were more things that could go wrong with our integration tests, and more things affected the bunny. So either depressed bunny flakiness, data issues could cause the sad bunny, deployment issues could cause the sad bunny, an environment could be causing the sad bunny, could be a bunch of different things. And as soon as you start seeing the sad bunny for somewhat a significant amount of time, the don't care syndrome comes in. Anyone aware of the don't care syndrome except for Baruch? Right. So as soon as your integration tests become flaky, as soon as they're like, oh, it could be somebody else's problem, right? Somebody else broke the build. Somebody else broke.
It's probably the environment.
It's probably the environment, right?
It's always the environment.
It's always the environment,
yeah.
right? So this is the don't care syndrome, and it's a self-fulfilling prophecy. Every single team I talk to, sooner or later, this comes down to this. The bunny becomes sad and depressed. And as a project matures, as a project gets more and more tests, as you have more and more code deploys, eventually the bunny gets depressed. And there are solutions around, you can do more environments, you can do, sooner or later, the bunny will get depressed. So what do we want, right? To avoid the depressed bunny problem, we want, production-like feedback, and we want it locally, and we want it fast. All right? How do you do that? We believe that the answer is self-contained tests. Some would call it hermetic tests that are real tests, not just mocks, that actually have real dependencies, that do not depend on any centralized resources. Right? They're self-contained. They have everything they need in order to get running. There is no dependency between tests. That way you can run multiple of them at the same time. They're treated as code, same life cycle, right? So you don't have to spin anything else up. And allow you to do clone and run. So you can just clone a repo, have the test, get it running, off you go. Right? But how? I'm going to argue test containers is the answer. Somebody else had to pay for me. There we go. I'm going to talk about test containers.
You pay your own bill, liar.
A what?
You pay your own bill.
There we go. All right, so I'm going to do a quick demo. Most people who were here, who answered the question that Baruch asked, actually said, you all know test containers. Most know test containers? Anyone wants to see a demo? Should I skip this? Oh, demo. All right, demo. All right, cool.
It will probably fail and it will be fun.
It will be fun. There we go. All right, cool. I'm gonna do this. I'm gonna go into my IntelliJ. I'm gonna do this. I'm gonna just show you a quick class over here. This is an abstract class in Spring. S3 was written in Spring, by the way, back in the day. What I'm doing over here is I'm defining a Redis instance, a Kafka instance, a Postgres instance. This is all the setup that I'm doing, literally 6 lines of code. Telling where hosts are, setting the bootstrap servers for Kafka, and the JDB, and the connection strings. And then I'm able to do a real integration test, which is going to inherit from this abstract class, which is going to start the application, and is going to send requests against this application. And what I'm able to do over here is I'm able to just go and press run. And if demo gods are going to be with me today, and they seem to be, what's happening over here is as my application is being stood up, I'm spinning up Redis, I'm spinning up Kafka, I'm spinning up Postgres over here. It's going to start my application. It's going to run my code against those, if I'm lucky. And maybe it will also be green. Let's see. Tempting to see.
It's 50-50.
50-50.
Either pass or fail. Always 50-50.
There we go. All right, there we go. It's green. So, awesome. There's a bit of delay. So what happened over here? I stood up my application. I loaded data. I stood up all of its dependencies. And I was able to do a test, complete end-to-end test, integration test, without depending on anything else, right here from my local laptop. All of this, I lied. It's completely free. It's open source. You can do it today go to testcontainers.com, you're able to see it there. I'm going to go back to my presentation over here. There we go. Oh, there we go. All right, cool. All right, so this is not just Ellie talking about this. This is actually used in a bunch of companies. So a bunch of companies do talk about using test containers. Spotify last week, they actually sent us $25,000 as a free open source donation to the test containers project. Uber talks about using test containers. They have like 30,000 tests as far as we know. Netflix talks about it just recently about using test containers. Spotify actually talked about, when they gave us the prize, they told us that they test every single one of their service with test containers. And you're able to use test containers with almost everything that's available as a Docker container. We have convenience methods for over 50 different technologies out there. So almost every single database that's out there, every single message broker, even cloud emulators. So there are local stack emulator for AWS, which AWS is not happy about, but that's beside the point. Google has their cloud service emulators. Azure has their cloud service emulators. You're able to do it with almost any technology that's out there. You can also spin up your own services as dependencies, as some people do. This was nice, right? This was all free open source, great, awesome. But we can go more. We can go even deeper. All right, so Baruch talked about the pillars of GPE. That's the t-shirt I'm wearing today, right? So we talked about foster faster feedback, but we can go even further. All right, test observability and debugging. While I showed you what you can do with test containers, what we have done over here at Atomic Jar, the company that is paying for me being here today, right? We built test containers desktop, which is a battery-included experience, which is an application that you can install on your machine, a free application for developers that allows you to freeze containers shutdown. So test containers by default brings up, starts your application, brings up all the containers, and then when you're done, shuts them down for you. With test containers desktop, you can say, hey, do not shut those containers down. I want to be able to go and debug and see things. It allows you to do service configuration. So by default, test containers in the open source starts all of your services on random ports. This allows you to map them to well-known ports. It gives you reuse of containers, and as a small added bonus, we actually made it work without using local Docker. So we now have embedded runtime that we released 2 weeks ago, but who's counting? All right, I'm going to do a quick demo of what this actually does. All right, so I'm going to switch over to the same code that we were looking at. I'm going to set a breakpoint over here. This is a test container.
We don't see him because you're on presentation.
Ah, smart. Thank you, Baruch.
Oh, here we go.
I was quietly, There we go. So set the breakpoint. This is a test containers desktop application. Please note the latest build running on my machine. It was baked today. All right, but
Bleeding edge.
Bleeding edge. So what I'm going to do
Like the
over
bunny.
here, like the bunny. There we go. All right, I'm going to run this test in debug. Right, so it's going to do all of the magic that I showed you before. It's going to spin up all of those dependencies, all of that stuff. And it's going to hit the breakpoint in a second. Dun, 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 dun. Sweet.
Maybe your boss will get you an M3 next
Huh?
week.
Yeah, maybe my boss will get me an M3. I'm not sure. I can use the cloud in a second. All right, cool. So there we go. So what I have over here, I said freeze my container shutdown. I have mapped Postgres. What I can do is I can do open terminal. And what it will do, it will open a window that is a terminal to that particular container that I have running. And what I can do just SQL -c test. Oh, there we go. I can see what are the talks. I can do select star from talks. There we go. So what I was able to do is I was able to run a test containers-based test. I was able to freeze container shutdown, so I can now log into that particular container. I can now log into that container and see what's inside of it as I'm debugging my software over here. All of it is running locally on my local machine. All of it is available if you use Test Containers Desktop, which is free and is available at testcontainers.com. There we go. Right, but we can go even further, right? There is, we talked a little bit about what you can do with your local development environment. We talked a little bit about what you can, how you can go and dig deeper into test containers-based code. We've built Test Containers Cloud, which is a cloud backend for your test containers. So as opposed to spinning up your test containers locally, you can now spin them up and run them up in the cloud. And that gives you, consistency, whether you're running on a Windows or Apple Silicon, as Baruch has suggested. M3 is coming out, so many of you will be running M3. So if you want a consistent experience between various team members on your team, that gives you that. Docker and Docker issues with test containers? Anyone run into them? There we go, a few of you. So if you run into Docker and Docker situations in your CI, you can hook up Test Containers Cloud and spin up those containers up in the cloud. So no more Docker and Docker situations. Turbo mode, so when you're running your test containers-based tests, we can give you many more machines than just your local machine. And then team and enterprise visibility into what you're doing. You get this beautiful dashboard that gets you more insight into each individual test run that you're doing. You can see visibility into what containers are being used on your team. So if someone is testing this Cassandra 3 and the organization is trying to move from Cassandra 3 to Cassandra 4, you can see who's testing with what. And you can see a lot more visibility into your whole teams and enterprise usage. It connects to our backend through encrypted tunnels, and you can't really see the slide. Awesome. We have over 30 edge locations to make sure that you have locality and that you can have low latency when you are using Test Containers Cloud. With that, I hope I have helped you. I've helped convince you that Test Containers is DPE and helps with developer productivity. With that, Baruch?
Well, let's wrap it up. So yeah, the only thing to mention is that the gains are real, not only but what you feel right now, and I hope you feel right now like, yeah, we need to do it. I mentioned that a lot of companies already do that, and they report back. And they report really incredible numbers. 84% of people of organizations who embarked on this process of developer productivity engineering actually report that it dramatically improves productivity. My favorite slide is this. The same, probably 84%, probably the same people, reported that developer productivity engineering fosters developer joy. I love it because it brings memories from my childhood. And I hope it will bring yours as well. Recall first time you start programming. You wrote code for the first time. I bet it was joy. Because you created something out of nothing. Remember that? And then WebSphere, basically. Let's bring it back. Let's bring back the joy. The way to bring back the joy, for me at least, is developer productivity engineering. You are productive, you create something, you are not frustrated. This is joy. So with that, speaking.jbaruch or this QR code is the same URL. You can take Gradle and Maven speed channel over there, speed challenge over there. It's just speed up your own build. If you are afraid to run it on your own build, we have ideas of open source project that you can play with. DP agent of change. You are all like, hey, let's do DP. You come tomorrow morning. Okay, what do I do? We have a lot of resources to help you to convince your organization and will win prizes while doing that. They are all arranged as challenges that you do and with prizes. Pretty cool. DPE handbook is there if you want to learn more about DPE, and the DPE Summit videos that talk a lot about DPE in general, test containers in particular. Spotify talk is there talking about test containers. Netflix talk there talking about test containers, a lot of good stuff as well. Also there, test containers URL when you can download test containers for desktop, and the URL to join test container Slack if you have any questions or want to participate there. I think Gradle community Slack is there as well. A lot of resources at speaking.jbaruch. With that, thank you very much. We actually have 10 minutes for questions, surprisingly. I'm Baruch at JBaruch. This is Eli at Aleyner, and this is Toronto JUG. And this is the hashtag that we just hijacked, so don't forget to use it when you praise this talk on social. Speaking.jbaruch, the slides are there, the video going to be there, all the links. Thank you very much. Okay, questions, also known as tech support session for test containers.
There we go. That's what it was the last couple of talks.
Yeah. No, but if you have obviously other questions, we're more than happy to.
The test prediction thing.
Yeah.
Is it available with the enterprise version only?
Yeah, it is a part of the Velocity, a product formerly. So, the Velocity used to call Gradle Enterprise. I hated this name because it's not only Gradle, it works with Maven and Bazel and SBT and you name it. And it's not only for enterprise, it's for everybody. So I'm like, we have to rename it. And then we renamed it. And now no one recognizes the name. So I'm going about like the Velocity, the product formerly known as Gradle Enterprise, and it's much worse. But it will get better over time. Yeah, it's a feature of the Velocity, but in the spirit of convincing you not buying it, the paper is free and open source. It's an interesting engineering challenge to implement. And when you give up, and you will buy the Velocity anyway, so I'm good.
And with Velocity, is the actual build run in Gradle Cloud, or it's the build run in CI/CD and it just fetches?
Oh no! It's all everything I talk about. I don't care about CI/CD, but my JFrog ways years are out of the window. Don't care about CI/CD. Local build all the way. It is a cloud service in terms that you go to a URL to observe your build, but the information comes from your build tool. Your Gradle, Maven, Bazel, SBT reported what we call a build scan to the system, and then you can compare between them, you can dive into them. One of the most exciting things is collaborating through effective tooling. Every view, not only every page, every view, every setup of the filter, every search result are linkable, so you can send to your colleague, hey, the bunny is bloody because of you, with the exact pointer to what they did wrong. Thank you. I didn't pay him, by the way, but I should.
Amazing talk, by the way.
Thank you.
So I came back from a Spring1 conference one time, and I heard about test containers, and I got super excited about it, and everything worked great locally. And then I ran into the Docker and Docker issue when I tried to push in my CI/CD. And I work in a highly regulated industry, so hearing about test containers cloud is fantastic. Is it only, like, do you only offer it as SaaS, or is test containers cloud possible to be brought on-prem?
So today it's SaaS. So people ask that of us fairly regularly. When we talk about this, what we spin up in Test Containers Cloud is usually your containers and test data, usually dummy data. And then we went and we talked to some companies and offered them, hey, Test Containers Cloud is control plane and data plane. We can put the data plane, try and putting the data plane in your subscription on your location, so it never reaches us. And we actually did the pilot with a couple of companies, and most of them said, you know what, it's too much hassle, let's just use a SaaS, because we're not sending you any sensitive information. So if that's an option, we'd be open for that. If the environment is such that, hey, you need to live in a submarine, we can talk.
Okay.
Basically, depends on how much you pay.
Thank you, Baruch.
Someone has to. Yes.
So you mentioned that it's a good idea sometimes not to use your own processor if it's not M3, but run tests on the cloud.
Yeah.
Is there any tools for that?
Of course, and you know the name by now. The Velocity has a test distribution feature that allows you to, it comes with, so you set up agents, which can be whatever you like, S3, Kubernetes, and then we don't care where it runs. You can run it or any cloud. And the Velocity will take the local tests and will distribute them among those agents. Not only it will give you more computing power to run the tests, you can also separate them by, for example, operating systems. You can have agents that run different operating system than your local machine, and this is how you can run your local tests. We're not talking about CD. This is all local tests on any architecture with synchronous feedback as fast as possible. So this is pretty cool. Yep. I didn't pay this gentleman as well. I need to buy you all a beer, I think, for that. My boss will pay. They won't. Yes.
So since we're talking about test containers, and you mentioned that we can test cloud stuff, cloud resources. Like I'm kind of building Kubernetes now, and my software talks to Kubernetes on Azure all the time. And it would be nice if I can have something local and fast instead of like calling the Kubernetes and waiting 10 minutes. Do you have stuff with that? It's like emulate Kubernetes?
So you can spin up, there is a module in test containers called K3, which spins up local Kubernetes, and you can deploy to that one. So it's not exactly AKS, right? It's not the Azure Kubernetes, but it is Kubernetes that gets run in a container.
Thank you. Yeah,
And then you run it, and then you run it in your CI, and you get Kubernetes in Docker. What can possibly go wrong? And then inside this tiny Kubernetes, you run more Dockers.
Yes.
Obviously. Yep. Nice. Yep.
So, Aleyner, the next couple of years, anything you sort of hoping test containers will sort of be like, or what's sort of the big vision for it, would you say?
So we are extending the number of modules. What we're also doing is we are partnering with many of the technologies behind the module. So we're making the modules official. So we're having the database vendor, the Kafkas of this world actually start maintaining those modules and recommending them. We currently have 8 or 10 of those partners that are doing that already, and we're many more in the pipeline. We're extending the number of languages that test containers support. I didn't mention it. It came out of the Java ecosystem, but there are currently 10 languages that you can use test containers with. We employ many of the maintainers as a company, but there's many coming out of the community. 2 weeks ago, we had someone publish test containers in C out of all languages. We're going to iterate a bit on what you can do with test containers. Open source, lots of ideas internally, how we can extend it even more than what it is today, but not yet something we talk about.
And tons of stuff in Test Containers Desktop.
And tons of stuff in Test Containers Desktop and Test Containers Cloud.
Yep.
What we're trying to do is we're trying to take the open source library and make it better to use through some of the efforts we're doing as a company.
Yeah, so for applications that are built with microservices, like another testing approach that's sometimes advocated is like contract testing, right? Which is, kind of like mocking, I guess, but more sophisticated. And certainly if you have like a lot of microservices, the idea of running them all in test containers is maybe still kind of slow. Like where do you personally see like the trade-off and like when you should be running other microservices in test containers versus like looking at contract-based testing or something like that?
So this question comes up a lot, and we actually believe that Test containers is a solution. So when we talked about, you mentioned microservices, and the question is, why did we create microservices to begin with? And the idea of microservices was, hey, sure, we can have less code, but the idea is that each team could iterate independently, right? The challenge with microservices is when you're trying to deploy them to some kind of environment, all of you run into each other and we get into the depressed bunny problem. Test containers is a solution for you to be able to iterate quickly on your particular service, getting all of your dependencies and iterating on your service. Now, contract testing is actually a great complement for test containers. When you're talking about composition, when you're talking about a sophisticated system where you cannot spin up the whole system. So one of the companies we work with a lot is Netflix, right? Who can stand up a version of Netflix on their local machine or doesn't happen, right? But each team still wants to be able to iterate on whatever they're building. Some companies try to implement contract testing, and we support that, and we believe that it's great. Some of the challenges with contract testing that we've seen is that in order for folks to benefit from contract testing, it needs to be adopted by the whole organization. You need both the producers and the consumers to implement this. It's a bit challenging, and we've seen people who are successful in it, right? But it requires a push from the top to everyone in the organization. Something like test containers is something that each individual developer can bring into their project and start getting value. And then as the whole organization adopts something like Pact or adopts something like Spring Contract, sure, you will get benefit out of that as well. But we believe that the two work great hand in hand.
You know what else complements all that? Predictive text selection. If your model tells you that you don't need to run a certain tests which are dependencies for other microservices, you don't run them. And it solves the problem of the performance of even the most performant of your tests, which are test containers.
Thanks.
Okay, I think we are going to get kicked out of here. Maybe last one, if it's short.
So last time, like a couple of years ago, when I checked test containers, test container Java, there was a hard dependency on JUnit4. Like if you want to use test container, this dependency will be brought in transitively. Has it changed since then? Can I use it without JUnit4?
We heard this question yesterday, didn't we?
This was day before yesterday, and the answer was a no, but I can go and take a look into that. So I'm happy to come back to you with that one. Second time this question comes up, and I should.
Yep. Yes. Thank you very much, folks, for coming, and enjoy your dinner. All right.
Got some stickers that Igor brought. We have Spring Boot.
Oh yeah, and we didn't raffle the shirts. So best questions.
Yeah, please.
JUnit4.
Yeah, there we go. That's
There you go.
speeding them up.
And where is the gentleman that asked me great questions about the velocity without knowing that he is asking about the velocity? Yes. Thank you very much. Oh, here we go. We got the lights. Sizes, I don't know. That's 2XL.
We gave away the good one.
Okay, that's no, that's M. That's L. If you don't want L, you want L.
What's this?
No, L.
L? Okay.
Yeah. Double XL. There you go. Okay, and this one we just throw at people. Woo! I didn't hit anyone. For bad or worse. Okay.
Thank you very much for your talk. Спасибо большое.
Ну, не за что. Я надеюсь, что понравилось. Сейчас, секунду, я
I should have mentioned the ROI though.
Oh yeah, you forgot. It's important.